This is the video introduction to Experiment 11 in Mr. Circuit Lab 1. This experiment will demonstrate how a 555 timer IC works. The 555 timer was invented by engineers who needed circuits that would generate many different pulse rates and duty cycles. A 555 timer is called an integrated circuit because it has many different circuits inside of it. To use a 555, an engineer has to see the spec sheet to see what electronic components are needed to be connected to its leads to make it output a variety of timing pulses. A 555 timer has 8 pins. They are numbered 1 to 8. There's a mark or indentation on the top of the 555 which helps you find pin 1. If you hold the 555 timer looking from the top with the mark on your left, pin 1 is the pin on the lower left. You count the pins in a counterclockwise direction. Our experiment circuit has 5 components connected to the pins of the 555. There are 3 resistors, a capacitor, and an LED. The values of these components determine the pulse rate of the LED. Our circuit is designed to give us a pulse rate out of pin 3 of about 1 pulse per second with a 10 microfarad capacitor as shown. If we increase the value of the capacitor to 100 microfarads from 10 microfarads, the pulse rate will slow down considerably. If you want to know the exact calculations, you have to refer to the spec sheet for the 555 timer. All right, let's wire up the circuit. Okay, this is experiment number 11 in the Mr. Circuit 31 lab that I've wired up for you. You notice that we have the 555 timer, a capacitor, an LED, 3 resistors, and 1, 2, 3, 4, 5 jumper wires, and a battery snap. Now, what we're doing here is connecting components to the exterior of this integrated circuit, which the spec sheet tells you to do in order to get pulses of about 1 time a second that will appear on that LED. So let's connect it up and watch what happens. Look at that. Bing, 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 bing. It's even a little faster than 1 every second, I think. Now, if we were to change the capacitor and take this capacitor out, the 10 microfarad, and we put in 100 microfarad, we have to do it in the right direction. I believe that it goes in right there. And if we put in 100 microfarad, watch what happens. Nothing. Oh, see, I had to be patient. With 100 microfarad, it's very slow in blinking. So if we put back the 10 microfarad, we'll notice that it blinks about once every second. So here we go. All right? So now let's talk about this little integrated circuit here. It has a notch on one end right here. And when you do that, when you find this notch, this is pin 1, 2, 3, 4, 5, 6, 7, 8. It goes counterclockwise. So wherever you have a notch or a pin or whatever right there, maybe you'll have a little notch, it's the pin 1 is right here. So the same thing I put over here on the diagram, you can see that we have pin 1, 2, 3, 4, looking from the top, 5, 6, 7, 8. All right? Okay, why don't you get your parts, wire up the circuit, and see if it'll do the same as mine did.